Without losing your precious time, we are moving on to the next speaker, who is an internationally renowned security expert, who has a presentation that if you ask me what it will be about, I have no clue because it's so secret that it's only in his computer that is going to be attached now. I don't have any clue what he is going to talk about, but I know that it's going to be safe, it's going to be secure, and it's going to be very interesting. Once again, welcome Rob Drewery.
Hi there, everybody. Okay, so today we're going to be fundamentally talking about long-range surveillance and how it's applied. As an introduction to me, I'm Rob Drewery. I cover the tactical security element for Motorola Solutions. My background is thermal imaging from Silent Sentinel. So let's just jump into it. We're going to stick to 20 minutes if we can, because it's nearing lunchtime and people tend to get a little bit grumpy at this time of day. So why do we use thermal imaging cameras? Fundamentally, in long-range applications, it's so we can see further and see things better at further in more conditions than daytime. We intend to look for targets at distance, threats. We also have other benefits to these types of systems, such as a good return on investment. We can then deploy less infrastructure. Cameras that can see further can clearly see further, but it means you need less of them. So whilst cameras in this sort of market space are really quite expensive, we need much less of them. And because we need less of them, we don't need as much recording infrastructure, we don't need as many operators, we don't need as many masts, communications. So there are many, many benefits to having long-range visibility, putting aside the fact that you can actually see further. And also to touch, most of the environments where the cameras are deployed are really quite harsh environments. So in the Baltics, where we have cameras deployed, one of our main challenges is ice and really the minus 55 to minus 40 temperature ranges. Conversely, we also have other issues in the Middle East, or the Mexican border in the USA as an example. So we're running to try and meet temperatures of plus 65 ambient temperature. So when the sun shines, you can cook your breakfast on the cameras. So that's really where we apply these cameras. It's very rare that we have a long-range camera in a nice part of the world. You wouldn't see them in a city centre. You would generally see them where most defence and military applications sit. With that in mind, we're just going to touch on a few user cases or markets where you would tend to see this type of equipment. So mainly, you're going to be looking at defence, military, maritime coastal security, and border security. Those are your three main verticals for this application. It's where your threats live. It's where you're going to see your government entities, such as your border force, your military police. You've also got your Coast Guard, which in most countries is classified as a military organisation. And unusually, we have certain countries with the Coast Guard where there is no coast, but they're still called the Coast Guard. We also jump around into aviation for airfields, not necessarily just airports. We're talking air bases for the militaries, so we have deployments in the US, many US Air Force bases. Law enforcement and police, we have cameras deployed on their vehicles for mobile surveillance. And more recently, counter-UAS and critical infrastructure, very much linked. And I'm sure everybody is aware that in Europe at the moment, there's a bit of an issue with drones, and it's potentially coming from not too far away from here. So that's really a key focus, and there's a lot of visibility on that at the moment. It would be fair to say that the counter-UAS market has been around for about 10 to 15 years. It's been around longer in military, but unfortunately, it's becoming a bigger problem these days. So, in the past, people liked the idea of a counter-drone system, but they didn't like the idea of actually spending the money to buy one, which is now starting to change. So for the sake of today, we're going to touch on military applications. The defense and military applications are quite varied. So we've just put a list here of how you may deploy it in a defense and military application. So most scenarios, it's perimeter security. You're looking to defend an asset. You want to understand if there is a threat approaching you and mitigate that threat or take an action before that threat actually arrives at your asset. That asset could be your fence line, it could be a power station, it could be an air force, it could be anything. We need to, the concept being is we're trying to understand what that threat is, if it's not a threat or if it is a threat, as early as we can. It's all about time. Ultimately, we're not going to stop that threat in many instances, but we're going to react to that threat. That largely jumps into the border security application, which is really another angle on this. Border security at the moment is another high-profile topic. In Europe, generally speaking, the main border of concern is obviously the Russian border. That's along through Finland, Poland, Estonia, Latvia, Lithuania, and further on the coast. The borderline. There has been activity on that border for the last 10, 15 years, but obviously the events in Ukraine are making that more and more important. So there is a lot of activity there. We're also looking at coastal security. We find that in that environment, what we're finding is that the vessels are spoofing other vessels. So we have the Russian shadow fleet. They will take an identifier from a fishing vessel. So when it's passing by radar or an AIS transponder, that vessel looks like a fishing vessel. The only way you're going to know if that vessel is not a fishing vessel is by getting a camera and looking at it. So you may see on coastlines that the deployment of long-range cameras is becoming more prominent because we need eyes on those vessels to verify exactly what they are. And then obviously the Coast Guard will send a helicopter or a patrol boat to take a look at that. We also jumping around into rapid deployment kit. A rapid deployment kit is fundamentally 3 Peli cases with equipment in that's self-powered. It's ideal for tactical surveillance where a soldier may need to look at an area of maybe 2 to 3 kilometers at a safe distance, especially with a thermal camera. The idea is it's deployable within 5 minutes, so you drive up with a vehicle, take it out the boxes, put it on a tripod, have a look around. And you may want to link that to a wider system, and we'll jump onto that in a moment. Counter UAV, we've just touched on that. So counter UAV is a very wide subject. There's many technologies in counter UAV, such as radar, RF sensors, types of drone, distance to the drone, the mitigation of the drone. There's an awful lot of compliance. You can't just jam a drone in an airport. Airports don't particularly like that because if you shoot a jammer at a plane, it may also damage the plane and compromise the plane. So there's a lot of policy around using counter-UAV systems at an airport. You'll typically find that the person in an airport using the jammer is usually a police or military authorized person. And then we finally have patrol vehicles. So they're rapid response vehicles where the camera's generally fixed onto the vehicle. You might find there's a radar on that vehicle as well. So you may see that drive up to a part of a border where you've got a blind spot and you just need rapid surveillance that's generally temporary. So when we're jumping into the defense surveillance space, it's not just a camera. It's an ecosystem of technologies to provide a solution that works for the end user. And then we basically fit the technology to make sure that it meets their requirements. This is an example of a typical border gate, sort of border post, where we've got many technologies here that provide really whatever you need. We don't need everything. Sometimes it's simplistic. Sometimes they just have a camera and a gatehouse. In this instance, we've got counter-drone, we've got command and control, and then as part of the wider Motorola solutions, we have the radio piece, the communications piece, which is usually in place in most countries. Fortunately, being Motorola, we've got quite a lot of access to infrastructure. We've recently acquired an organization in the US called Silvus, which offer high security, high bandwidth radio transmission. So we're starting to see that come into play. You know, that technology is not just on land, it's put into drones. So you can then use drones as a tool to do reconnaissance rather than just intercepting drones. So we're going to focus a little bit on border security. So what you're looking at is a typical, very basic, but typical border scenario. The main part of the system is to detect a person. And we may use ANPR, we may use radar, we may use other sensors like PIDs, fence detection systems, we may use buried cable. We then present that on the user screen. You can see as an example here, this is using a software called SR7, so that's your C2 or your command and control software. That allows the operator to see what's going on. It interprets data not just from the camera, it will interpret data from the radar and allow you to have a workflow. It will show you that target moving on the map without having to use the camera. It's at that point you will select that target. The software will then basically follow the camera, ask the camera to follow the target. And you can see on the top left, we have many different types of radar. Radar can range from, 500 meters to 25 meters. And the price is typically going to go up with that extent as well. And then the last part of, the reaction is you've got to then coordinate your response to the threat. You may send a vehicle, intercept it. You may, if it's a defense scenario, you may be actually actioning soldiers to come along and take out the target, which is all part of the response, but it's a measured response. A couple of case studies. So we've put this into action. This is a scenario of a trial that we've been doing on the French-Italian border. They've got a big issue with immigration, or illegal immigration, should we say. We see this issue around southern Europe quite a lot, in Montenegro, Croatia border. Generally speaking, wherever there's a land access to Europe, we're going to see issues arise. So as part of this solution, we have an air-on camera. This was a relatively short-range solution because we don't have the line of sight. So we have an Echodyne radar, an air-on camera, which you'll see possibly a human at 3 kilometers away. We then have fixed assets, so the fixed cameras monitoring key points on the area, recording all of these images on the MBR. The interesting part comes on the right-hand side. What we're doing there is now catching people. I'm going to jump onto the next slide because that's a little bit more interesting. During this trial, it's interesting that this was a live trial. We were there for 3 days, and during that time, we managed to catch around 10 to 12 illegal passings on that border and made three arrests. So the business case really presented itself in that instance. But what we're doing here is we're not just utilizing the radar. If you look at the bottom left screen, we're also using the Motorola technology. We have a Unity NVR with an analytics package, so we can actually suck in camera streams, not just from my camera, from any other camera, and we can record that and perform analytics. So if you know that your person or your threat is a red car or a person wearing a red jumper, we can put that search criteria into our software. Not only will it search your estate of cameras, perhaps around your buildings, it can also search the content of the long-range cameras. So there's a very big piece of intelligence there that you would not normally achieve from just a simple long-range expensive camera. In a more typical border scenario, we start to look at this scenario. We're using a Jaeger, which is our long-range platform. Again, we've got C2 software here. In this instance, we didn't have a radar. So we are simply using a basic system of third-party video analytics. We're looking down a sterile zone. And this is the demilitarized zone with Syria, Israel for the UN. It's quite a lively area. And these are sat on outposts which tend to get damaged accidentally. But that's really how we would deploy these cameras. And you can see the view here from one camera. We're probably only looking maybe at the short range, probably about 1 kilometer. But if you look in the distance, you can see probably about 4 or 5 kilometers. What we would then do is have multiple cameras. We don't just have the biggest cameras, we have the smaller cameras to gap film. But again, we try to keep the camera count down to a minimum. So rather than bore you a bit, we'll just show you a quick video of some tracking and just show you how these things look. Hopefully this is showing all good. So when we're talking long-range cameras, we're not just talking thermal, we're talking visible cameras. Video tracking is a different animal to conventional CCTV. It works very differently. We don't have the luxury of just detecting a target. You need operator intervention. There's a lot of things in that scene at distance. You really only know they're there at, say, 4 or 5 kilometers once you've zoomed into that target. So you need a radar to find that target so you know that it's there. This video will illustrate this a bit more. This is a cooled thermal camera. Hopefully it will give you an idea. So the camera technology is evolving. 4 or 5 years ago, we never had HD thermal cameras. They were far too expensive. More recently, in the last 2 to 3 years, you would say HD thermal cameras are starting to be more prominent. And this is just an example of the quality that you can now get on a thermal camera. And we're starting to see the reliance more on thermal cameras rather than the visible camera. So we would reduce the cost of the visible camera to a short-range camera for just a little bit of situation awareness. And then we use a thermal camera to be our main eyes. And as you can see, they do see quite far. And we'll show you some really long-range stuff. So this is on the west coast of America. This is ideal conditions. So ideal conditions for a thermal camera: low humidity, desert type scenario with high contrast targets. So the heat of the sun is warming up the targets. And I'm just going to let it run because we have one more video, which is the more impressive one. So this is going to run out. Really, this is about as far as you will ever see on a thermal camera. It doesn't matter how big the lens is. This is how far you will see, mainly due to atmospherics. And that's 67 kilometers at the top. Okay. So let's just see what that looks like in reality. So these are the ranges of these cameras. The top one is the detection of a vehicle. The bottom one is, the white is the detection of the vehicle. The black is the detection of a person. I'll touch on this if we have time, but I can answer questions later. Take those ranges with a pinch of salt. We say that because you have got atmospherics, location in the world to contend with, which will affect those ranges. So if and when you need these things, come and speak to us. We can do the modeling to where you're going to deploy these cameras. Okay. Just obviously going to punch my own products a little bit. So we have the air, and on the left, one of the main points of our cameras is the accuracy. When we're dealing with long-range optics, it's not about how quickly you get to that target. Our field of view at 10 kilometers is probably 300 meters wide. We don't want to be moving fast. We want to be moving as slow as we possibly can so we don't overshoot and miss the target. Or when that radar sends our Jaeger camera, which is here, that field of view on that cold thermal camera is something like 0.6 degrees. That's why you need a radar. You can't do video analytics at 0.6 degrees, and you need to zoom into that target at 10 kilometers. And when you get to that target and you want to track that target, you've got to be very, very slow and accurate, otherwise you will just miss it. Okay, measuring thermals. I'm mindful I've got 1 minute left. When we do thermal camera measurements, you'll see in the specifications that there's detection, recognition, identification, or DRI. Most of them are based on Johnson's criteria, which is a crude measurement that doesn't really take into account any atmospherics. It was created in the 1950s for the US military. It's very crude, it's based on old tech. But that's the world we live in. you can see there, it's based on 50% accuracy or probability of being able to perform that task. So I say I can do a vehicle detection at 44 kilometers. Well, if I'm in a maritime scenario, I can't do that because I'm humid, generally speaking, in the summer. Maritime atmospherics are really bad for thermal transmission, so you lose that ability to see that far. Your ship vessels are generally very similar temperatures to the water. So that 50% probability almost is, can that operator see that vessel? Maybe not so well. So we're going to then increase that probability to maybe 70, 80%, and that distance comes down. That's all the things that we have to contend with, which lends us to the MBIPM modeling. And this is a modeling that was created again by the US military, but within the last 10 to 15 years. And we can input that data into the software, so it's the atmospherics, the place in the world, the size of the lens, all the other characteristics. The upshot is we will get more competent, usable data. If we go to our Chinese competitors, they don't really care. They'll just use Johnson's criteria and say you can see the moon at 100,000 meters away. It doesn't really work, so just be careful. And lastly, complementary technologies. You know, have a chat with me later on, see what you want to do. And I just want to finish on one slide. It's more of a video, so just drone detection. Hot topic at the minute. Again, multiple technologies. It's a layered approach. It's a big system that is often custom built and designed to each specific application. So if you come to me and say, how much does a counter-drone system cost? I can tell you it's going to cost you between 600,000 euros or maybe 10 to 15 million euros. It really depends on what you're doing. What you're looking at here is our video tracker going in the camera. So I showed you a picture of it tracking a helicopter previously. This is now tracking a drone. But we can also track a human, vehicle, and vessel. And this looks relatively straightforward on the screen, but I can tell you now this is one of the hardest targets to track on screen with a heavy piece of kit that costs, you know, that weighs 100 kilos. And that's me done. If you wish to have any questions, I'm available later. And thank you for your time, and thank you to Maris for inviting me along. Thank you.
Thank you, Rob.